All right, now, I get here, I plug in a number into the first derivative, which is greater than 0, so what would be an example? 1. All right, so I cube 1, and I get a positive, so it's positive over a positive, so it's increasing. And we said it was, what we got negative 2 there? Negative 2 cubed would be 8. 8 plus 16, no, negative 8. Negative 8 plus 16 is positive 8, and you'd have a positive over a negative, so it would be decreasing. All right, so here again we got a situation. We had an asymptote here. There was no point there, but we did change from decreasing to increasing at that asymptote. All right, now let's go to the number line and look at the second derivative. Again, the second derivative is negative 48 over x squared. No, x to the fourth. And at 0, it's undefined. Now, if I'm not plugging in 0, it doesn't matter whether I'm plugging in a negative number or a positive number here. What happens when I raise it to the fourth power? It's going to be positive. So I'm always going to have a negative over a positive here. So it's going to be what?
Down.
Concave down everywhere. That's correct. So I'm concave down, concave down. All right. Are we good here? Can I?
Wait. Okay. So we knew. What was the whole purpose of getting the second derivative?
We know where.
Negative 48 over x to the 4.
Negative 48 over x to the fourth.
What was the point?
Well, I got to know its concavity. And it doesn't matter what number I plug in here, whether I plug in a negative or a positive, when I raise it to the fourth power, I'm going to get a positive. So I have a negative over a positive, which is always negative. So it's going to be concave down everywhere. All right. Are we good? Okay. Let's move on. The very first thing I'm going to do is graph my asymptotes. I'm not going to make a chart on this one. The reason I'm not going to make a chart on this one is because, and I could, I mean, that definitely wouldn't be wrong, but it's going to be concave down everywhere, so I'm not going to have to mix concaves up and concave downs anywhere, so, and plus, we're a little constrained on time. But I have a vertical asymptote that sits right here, and I have a slant asymptote that's y equals x. So I've got a slope of 1 passing through the origin, right? All right, now, what are my points?
2, 0.
I've got the point 2, 0. Okay.
0, 0.
I don't have 0, 0. And then down 3 point something?
Yeah.
So that's going to put me right below the asymptote in there. All right, now, from this, from here to here, I'm concave down, and I'm increasing. So I'm going to be on this side of my asymptote. So I'm going to be concave down and increasing. And I'm hugging the asymptote. So it looks like that. Now, it doesn't really look like it's concave down, but it is. Now, when I get to that 2.5 whatever, I start decreasing, but my concavity doesn't change. It's still concave down, and it's going to hug up against this asymptote. So I'm going to be concave down, and I'm going to hug up against that asymptote. And I've got a slope of 0 right here. Because it goes from increasing to decreasing, my slope of 0 is here, so it does that number. Now, what is everything to the right of my x-axis? I'm sorry, right of my y-axis. What is everything to the right of my y-axis in this case? It's concave down and it's increasing, right? So I'm going to be increasing and concave down, so I need some kind of a shape that looks like this. But I also need to try to hug against my asymptotes. So it's going to go something like that. And that becomes my graph.